Hi, I'm Tim Comperta, and this is my 8 puzzle solver. So we're going to start with hard because we're cool, and then we're going to do greedy or best first search. And so this leaves us with 66, 67 moves, and 278 as being the cost. And it only took a third of a second to run. Crazy fast. I like that. Alright, so now we're going to go over what the code looks like. So, I used the puzzle node and I made my own class for that, and it involves, so I made moves, which it takes a lot of the necessary information that I needed, and moves gives me the moves that I need. So down, up, left, right, and then move down, move up, move right, move left. Involve my moves method, and it produces, it's a successor class, and it processes what moves happen, and it creates a copy, moves it, and then creates another count of misplaced tiles. And so after that, we go on to the search algorithms. So we start with breadth first search, which uses a queue as a list for a queue, pops it up, appends it to the end, pops it off from the beginning, a classical LIFO, and it just simply appends the next following one if it's available. And I used a set for state checking, which just took the string of the position that I have, so the string of the list of positions, so it'd be like 1, 3, 4, whatnot, and so on, and it would take that as a string. DFS uses the same list, only instead of popping it from the front, it popped from the back, and so that would make it a LILO, and then create a stack rather than like a queue data structure in Java. So both of those used lists, and once again did the same thing. Also used a set for checking states. Used uniform cost search. So I also use a set for state checking, although for this time for iteration I used priority queue, which allowed me to sort, and I sorted by the G of n, which is the total cost of the node and the total cost to move the node to a specific position. And really the only thing changed is how to count the node, and I used the counter, and it counted for each priority number, and it gave me that's how many puzzle nodes had that priority number, and that's awesome. And so it just took the cost, comma, move right, which is the successor node, as a tuple into that queue. Then there's best first search, the one that we saw. It takes the priority queue, and rather than taking a tuple of total count and the puzzle node, it takes the tile count that are misplaced and the puzzle node as well. Very simple, very like. Then we have A star, which uses also a priority queue, only this time our first entry in the tuple is a misplaced tile count and the total cost to move to a certain puzzle position. And so that works better. And then our A star 2 is our Manhattan distance plus the total cost, and this one works the best. And so we have the total cost plus the Manhattan cost, and that is sorted by the tuple, which is all happy and dandy.